Hello students, this is Josna. Today I'm going to explain a small topic that is valency and very important topic. And before that, let me revise Bohr atomic model. So all of you know that according to Bohr, there is a nucleus at the center of an atom and the electrons are present around the nucleus in a closed circular orbits, and these are called energy levels. What are these energy levels? So they are having different levels of energy. Now we can denote these orbits as K, L, M, and so on. So K, L, M, the first one is K, second one is L, and third one is M, like that. Okay. So this is about Bohr atomic model. Now, so coming to our valency here. So what do you mean by valency? It is nothing but a simple definition, that is combining capacity of an element. So what is valency? It is a combining capacity of an element. Okay. So how do you know the combining capacity? So for that, you need to know octet rule. Okay. So let us move to the octet rule. So what is octet rule? Octet Octet rule. So, what do you mean by octa? Octa means the number 8. So the rule is depends on 8 number. So octet rule means if the atom has 8 electrons in the outermost shell, then the atom is more stable. If the element which is having 8 electrons in the outermost shell, that is more stable. Got it? The element with 8 electrons in the outermost shell is more stable. So usually the 8 electrons are present in inert gases. So that's why they are more stable and they have little tendency to participate in chemical activity. Okay, so according to octet rule, the inert gases have 8 electrons in the outermost shell. So in order to be chemically stable, the atom should have 8 electrons. So based on this rule, we can explain valency. See how. So before that, let me show you the pictures of different elements according to Bohr model. So this one. So in this case, first one, hydrogen, helium, lithium, beryllium, boron, and all these having different electrons in the outermost shell. So hydrogen is having 1 electron, helium is having 2 electrons, lithium 1 electron, beryllium again 2 electrons, boron 3. Like that, oxygen is having 6 electrons in the outermost shell. Okay, so based on this, we can explain valency very well. So please try to remember the fluorine, and in case of sodium, how many outermost electrons are there in fluorine? It has 7 electrons, whereas in case of sodium, it has 9 electrons. Let us see what is combining capacity is. Okay, now in case of fluorine, how many outermost electrons are there? 7. So to get octet configuration, how many electrons it has to gain? 1 electron, right? So if it gains 1 electron, then it has 8 electrons in the outermost shell. So it will be chemically stable. So fluorine always tries to get 1 electron to become stable. Okay. Coming to the sodium, this is about fluorine. And coming to the sodium, it has 9 electrons in the outermost shell. Okay, so if it loses 1 electron, then it will get 8 electrons in the outermost shell. So what is the combining capacity of sodium here? That is 1 electron. So valency of sodium is 1. So the combining capacity means how many electrons it may gain or lose to get 8 electrons in the outermost shell. Got it now? So valency means combining capacity. What do you mean by combining capacity? The number of electrons gained or lost by the element to get 8 electrons in the outermost shell. So I think you clear with this topic. So let me explain one more example. If you take oxygen, so atomic number of oxygen is 8, right? So how many electrons in the valency shell? It has 6 electrons in the outermost shell. So in the outermost shell, there are 6 electrons. So if it gains 2 electrons, then it will get 8 electrons in the outermost shell again. So it will get octet configuration. So it will stable. So what is the combining capacity or valency of oxygen? It will be 2. Similarly with magnesium, and if you take aluminum, let us see for magnesium. So what is the atomic number of magnesium? 12. So how many electrons in the outermost shell? Valence electrons are 10. So magnesium loses 2 electrons to get 8 electrons in the outermost shell, right? So the valency of magnesium is 2 here. Coming to the aluminum, atomic number 13, and the valency electrons are how many? 11. So it has to lose 3 electrons to get 8 electrons in the outermost shell, right? So what is the combining capacity of aluminum here? 3. Okay, got it? So in this way, we can find out valency of each element. So this is about valency. If you have any doubts, please feel free to ask me. Thank you very much.